Welcome back, everyone, to another deep dive into what our amazing students are up to in KOEIGO's STEAM course at Zion Christian Academy.
It's really exciting to see how much they're learning and how quickly they're picking things up.
Yeah, for sure. It's amazing. So last week they were working on traffic signals in Tinkercad, right? Designing them virtually.
Exactly. It was a great way for them to get creative and try out different ideas without worrying about, actual material.
Oh, yeah, that makes sense. It's like a digital sandbox where they can just experiment.
That's a great way to put it. And this week, they got to take those designs and actually build real traffic lights.
Wow, so they went from screen to a physical object.
Exactly. It's that, aha
Hmm.
moment when they see their code come to life and control something in the real world, like a real engineer.
That's awesome. I bet they were thrilled to see those LEDs start flashing.
Oh, absolutely. So let's talk about what they built this week. They started with a physical circuit using LEDs and resistors.
Right. Those are the key components of a traffic light. So can you remind us what those do again?
Sure. LEDs are those little lights that light up, red, yellow, and green.
Oh, yeah, of course. And the resistors, those little cylinder things.
Yes. They control the flow of electricity to the LEDs. They're kind of like making sure each LED gets the right amount of power.
Ah, so they're like protectors for the LEDs.
Yeah.
That makes sense. But it's not just about the hardware, right? They had to program the lights to change, too.
Right. That's where the Arduino boards come in.
Those mini commuters we've talked about before?
Yep. They programmed the Arduino to tell the LEDs when to turn on and off.
So the Arduino is like the brains of the traffic light, and the LEDs and resistors are the parts that actually do the work.
Exactly. It's like how our brain sends signals to our muscles. The Arduino uses code to send signals to the LEDs.
Code. So they're writing actual computer programs now.
They are, and they're learning some pretty cool programming concepts along the way.
Like what?
Well, for example, they had to figure out how to make the lights change at specific intervals to create that red, yellow, green sequence.
Oh, wow, that's pretty advanced.
It is, and it's teaching them to think like programmers. They're breaking down a complex task into smaller steps and then writing instructions for the Arduino to follow.
So it's not just building a traffic light. It's about learning how to think logically and solve problems.
Exactly. And that's a skill that will be valuable in so many areas of their lives.
For sure. But we're missing something. A traffic light isn't complete without a way for pedestrians to cross. What about that part of the project?
This week, they focused on that in Tinkercad. They designed a virtual pedestrian button that can interrupt the traffic light sequence.
So they're adding an interactive element to their design.
Yep. And that introduces some really important programming concepts like inputs and outputs.
Inputs and outputs. Can you explain those in a simple way?
Sure. Imagine a light switch. When you flip the switch, that's an input. The light bulb turning on is the output.
Okay, got it. So the pedestrian button is like the input and the change in the traffic light is the output.
Exactly. They're learning how to make their creation respond to signals from the outside world.
That's pretty cool.
Yeah.
And I hear next week they'll be building the actual physical pedestrian button circuits.
They are. It'll be interesting to see them apply their programming skills to make the physical traffic lights interactive.
I can't wait. But before we get to that, let's talk more about what they learned about programming this week. They tackled some pretty interesting challenges, right?
They did. Timing was a big one. They had to make sure each light stayed on for the right amount of time, just like in real traffic lights.
Right, because timing is crucial for safety.
Exactly. They can't have the red light only stay on for a second.
That would be chaos.
Oh.
So how did they handle the timing in their code?
They learned about a programming concept called delay. It tells the Arduino to pause for a specific amount of time.
Ah, so it was like a built-in timer.
Pretty much. And it shows them that even small details in the code can have big effects in the real world.
For sure. And you mentioned something earlier about inputs and outputs. Didn't they have to deal with those too?
Yes. Remember, the pedestrian button is an example of an input. When it's pressed, it sends a signal to the Arduino.
And then the Arduino uses that signal to change the traffic lights, right? That's the output.
Exactly. They had to write code that tells the Arduino what to do when it receives that input signal.
So they're teaching the traffic light how to respond to the environment.
That's a great way to put it. And that's a fundamental concept in all sorts of technology, from simple gadgets to self-driving cars.
Wow. It's amazing to see how these basic concepts can be applied to such complex systems.
It really is. And it just shows how important these foundational skills are for the future.
Definitely. Okay, well, we've covered a lot of ground today, from LEDs and resistors to Arduino programming and conditional statements. It's clear that our young STEAM students are really diving deep into the world of electronics and coding.
And they're doing an amazing job. I'm excited to see what they come up with next. It's inspiring to see them grasp these concepts at such a young age.
It really is. And next week, they'll be taking it even further, building the actual physical pedestrian button circuits.
That's right. They'll be putting their programming skills to the test, making those real-life traffic lights interactive.
Oh, I bet they can't wait for that. But I'm curious about this whole pull-down resistor thing. You mentioned it earlier.
Oh, yeah. Well, that's an important part of making sure the pedestrian button works reliably. You see, the Arduino needs a clear signal from the button. And sometimes if the button is a little loose or something, the signal can get messed up.
Oh, so it's like a safeguard to prevent false signals?
Exactly. The pull-down resistor keeps the signal off when the button isn't pressed, so the Arduino doesn't get confused and think the button is being pressed when it's not.
That makes sense. It's like having a backup system to make sure everything runs smoothly.
Precisely. It all comes down to precision and reliability, especially when we're talking about something as important as traffic signals.
Absolutely. So what were some of the specific programming challenges they faced this week? You mentioned timing was a big one.
It was. Getting the timing right for each light is crucial. Red, yellow, green. They had to figure out how long each light should stay on in their code.
Right, because in the real world, those timings are carefully calibrated to keep traffic flowing safely.
Exactly. And to do that, they learned about a programming command called delay.
Delay. What does that do?
It basically tells the Arduino to pause for a certain amount of time, like a little break in the program.
So they can control exactly how long each light stays on.
Yep. They had to use delay to make sure the red light stays on long enough for cars to stop, and the green light stays on long enough for cars to go through the intersection safely.
Wow. So it's not just about the sequence of the lights, it's about the timing, too.
That's right. And it highlights how even a small mistake in the code can have big consequences in the real world.
Definitely. But it wasn't just about timing, right? Didn't you also say they had to learn about inputs and outputs?
Oh, yeah. That was a key part of programming the pedestrian button.
Right, because when the button is pressed, that sends a signal to the Arduino.
Exactly. That's the input. And then the Arduino needs to respond to that input by changing the traffic lights. That's the output.
So they had to write code that basically says, if the button is pressed, then change the lights.
That's a great way to simplify it. And that's what conditional statements are all about.
Conditional statements, those sound complicated.
Not really. Think of it like this. If it's raining, then you take an umbrella.
Okay, so the if is like the button being pressed and the then is the traffic lights changing.
You got it. It's all about teaching the Arduino how to respond to different conditions.
That's pretty cool. It's like they're giving the traffic light a little bit of intelligence.
In a way they are. They're teaching it how to make decisions based on the information it receives.
And those decision-making skills are important not just for traffic lights, but for all sorts of technology.
Absolutely. From smartphones to robots to self-driving cars, conditional statements are everywhere.
It's amazing to see how these young students are already starting to grasp these complex concepts.
I know, it's really impressive. They're not just learning about traffic lights, they're learning about the fundamental building blocks of technology.
And those skills will serve them well no matter what path they choose in the future.
Exactly.
It's incredible to think about all the different areas these skills can be applied to.
It really is. And the students are picking it up so quickly. It's amazing to see.
So to wrap things up, I wanted to point out one more thing about this project. It's not just about learning to code or build circuits. It's about that aha moment you talked about earlier.
Oh yeah, that moment when they realize they can create something that actually works in the real world.
Exactly. It's empowering. It shows them they can take an idea from their imagination and make it a reality.
It's like they're becoming inventors, little engineers.
That's a great way to put it. And that's what STEAM education is all about, giving them the tools and the confidence to become the innovators of tomorrow.
Absolutely. They're learning to think critically to solve problems and to use technology to create solutions.
And those are skills that will benefit them no matter what they choose to do in life.
Exactly. Whether they become programmers, engineers, scientists, artists, whatever they choose, those skills will be valuable.
So to all the parents listening out there, I encourage you to keep talking to your kids about what they're learning in STEAM class.
Yes. Ask them questions. Let them teach you something. Encourage their curiosity.
Because you never know what amazing things they might come up with next.
Exactly. And we can't wait to see what they create in the future.
Well said. Thanks for joining us today, and we'll see you next time for another deep dive.
See you then.